Dear friends, in this video let us see colorimetric determination of copper. Now here we are estimating the amount of copper present in the given copper sulphate solution using photoelectric colorimeter. Now here we have the stock solution of copper sulphate. Now this is NH4OH, ammonium hydroxide, and we require 50 ml of standard flask. So we require many standard flasks, one to prepare the blank solution and others for the preparation of various concentration of standard solution of copper sulphate. Now here separately in a burette we filled with copper sulphate and here ammonium hydroxide. Now this is the photoelectric colorimeter in order to record the absorbance of the solution. Now here the principle is based on absorption of light. So how the thickness or how the depending upon the concentration of the solutions, mainly the colored solutions. So colored solutions can be analyzed using this experiment. So copper sulphate being colored, and that color can become intense by adding ammonium hydroxide. This is how we can estimate. In order to keep that absorbance to 0, we need the blank solution. So here in this blank solution we have 5 ml of ammonium hydroxide, then distilled water. After adding 5 ml of ammonium hydroxide, distilled water is added up to the mark, then shaken well for uniform concentration. This is called the blank solution. A set of copper sulphate solution is prepared at 5 different standard flasks. So here volume of copper sulphate range, in one standard flask we take 2 ml, other one 4 ml, 6, 8 and 10. So 2, 4, 6, 8, 10 ml of copper sulphate is taken, and for each standard flask we need to add 5 ml of ammonium hydroxide and the rest volume water. It is added water to make up to the mark. So 2 ml of copper sulphate, 5 ml of ammonium hydroxide, then rest is water to make up to the mark. Like that 4 ml of copper sulphate, 5 ml of ammonium hydroxide, rest water. That's 6, 8, 10, then 6 addition of 5 ml each ammonium hydroxide, then making up to the mark. Now here first let us add just 2 ml of copper sulphate solution from the burette. So after transferring 2 ml of copper sulphate, adding 5 ml of ammonium hydroxide. So on adding ammonium hydroxide, it forms cuprammonium sulphate complex. So that is dark colored. Then rest water. Then it is made up to the mark by adding distilled water. Now here we have the blank solution. So after placing the blank solution, the photoelectric colorimeter is set to 0. So we can read. So it has to be set to 0 by placing So now the instrument is set to 0 by placing blank solution. Now in place of blank solution we can keep the test samples. So here we have blank one, then followed by 2 ml copper sulphate, 4, then 6, 8 and 10 ml. So here from 2 to 10 ml. So concentration of copper ion is increasing. That is how the change in color also. Now this is highly concentrated solution. So 2, 4, 6, 8, 10 ml copper sulphate plus 5 ml each ammonium hydroxide, then added water to make up to the mark. Now this blank solution is to set the instrument to 0. Now using blank solution, the instrument already set to 0. Meantime, unknown volume of copper sulphate is given in the standard flask. For that also we have to add 5 ml of ammonium hydroxide, then make up to the mark by adding distilled water and keep it ready. Now, here in this standard flask, volume of copper sulphate is not known, unknown it is called, that you have to get it from the graph. Now, let us take the reading for 2 ml volume of copper sulphate. So, it is taken in a cuvette, then after drying the outer surface, it is carefully placed. Now, just reading the absorbance, that you have to record. So, 0.17 is the absorbance, that you have to record in the calculation part. So, 0.17 is the reading absorbance for 2 ml. So, similarly, we can take the reading for 4 ml and 6 and 8. Just before that, we can keep the blank solution to ensure 0 reading. Now, this is the sample containing 4 ml of copper sulphate. Now, here we will get the value 0.35, the same has to be recorded here. This is the value for 6 ml of copper sulphate. This is for 8 ml copper sulphate, 0.58, and here we have 10 ml of copper sulphate solution. It is 0.69. So, that also recorded here. Now, only the test solution is remaining. In the test solution, we do not know what is the volume of copper sulphate present, that you have to determine using these values. So, in order to determine the volume of test, we can use these 2, 4, 6, 8 and 10 as the reference volumes. Now, for the test sample, the absorbance we get is 0.53, that we can record here, 0.53. So, volume of copper sulphate is not known. So, using this optical density and volume, reference volume, we can find out what is the volume for this unknown solution, and later we can calculate what is the weight of copper present in the test solution. So, in calculation part, so stock solution contains 8 grams of copper sulphate, that is 1 liter. So, by taking molecular mass and mass of copper in that 63.54, 8 grams of copper sulphate contain, and we have 2.037 gram of copper present in 1000 cm cube of stock solution. Therefore, 1 cm cube contains 2.037 milligrams of copper. So, copper present in unknown test solution, cm cube into this one. Now, this A cm cube we have to determine. How to determine? By plotting the graph. So, here we have absorbance and reference volume. So, absorbance and volume of copper sulphate, you will get a straight line passing through origin. Then we have for test sample 0.53 absorbance, that we can use in this graph. As a result, we can get what is, so absorbance is this much, 0.53. Then from this we can get what is the volume of copper sulphate present in that test solution. Once we know this volume, that is A, that can be multiplied with copper present in 1 cm cube, 2.037. So, 2.037 milligram into A, that gives the mass of copper sulphate present in that unknown sample of copper sulphate. That same thing we can report in the form of result, the weight of copper present in the given test solution in milligrams. Thank you.